Welcome to video 13.5f. Use coordinates to find the length of the diagonal of a box. All right, here's example 5. Find the length of the diagonal of a box with a bottom base coordinates a, b, c, d as follows, and the box has a height of 10. Again, just to refresh your memory, we are now in 3 dimensions. The x-axis comes out towards you, the y-axis goes off to the right, and the z-axis goes up. Also, when they say to find the diagonal of a box, they mean to find the diagonal going on the inside of the box, across opposite vertices. If they set a face diagonal, that would be the diagonal on one face, but the diagonal of a box goes through it. All right, so I'm going to show you how to draw a 3-dimensional box just so you can get a visual of what's going on. And then I'll show you how to find the length of the diagonal by 2 methods. All right, so first to draw the box, I'm going to start with my x, y, z coordinates. All right, so I'm drawing a 3-dimensional coordinate system on a 2-dimensional surface. So this right here really represents the x-axis coming out towards you. All right, so I'm going to draw the bottom base and then just make it go up 10 units and fill out the box. So A is at 0, 0, 0. B is at 5, 0, 0. So that's the x, y, z coordinate. So 1, 2, 3, 4, 5. Just 5 units along the x-axis. Then point C is 5, 6, 0. So 5. Then what I want to do is go 6 units across. 1, 2, 3, 4, 5, 6. So that's 5 and then 6. And then 0, 6, 0. Don't go anything along here, just go 6 units that way. And what I'm going to do is it should form a parallelogram, so I'm going to make it so that it looks right. So it should be over there. 1, 2, 3, 4, 5, 6. Okay. So that's the base of my box. Now all I want my box to do is go 10 units up from each of these 4 vertices. Okay, I'll start at these 2. These 2 are easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise up there. Then, from these 2, go up 10 units. So again, it should be parallel, so I could kind of just make it so this is parallel to this. This is parallel to this. So there you have it. That's just how to draw the box. Okay, now what we want to do is draw a diagonal. So I could just draw it from this point to that point. And that's just going through the box. And I want to find the length of that diagonal. All right, I'll do it by 2 methods. So the diagonal is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So what I need are some coordinates. This coordinate over here was 5 by 0 by 0. This coordinate over here, it's not coming out, so it's 0 out. It's going 6 to the right, and it's going 10 up. So these are my 2 coordinates. All right, so it would be the square root, whatever I'll call these the 2's. So 0 minus 5 squared plus 6 minus 0 squared plus 10 minus 0 squared. That's going to be the square root of 25 plus 36 plus 100, because -5 times -5 is 25, etc. That's going to be the square root of, what do we have here, 30, 55, the square root of 161. And we're going to leave our answer in exact simplified form. Now let me show you just a little bit more intuitive and quick way. The diagonal is simply the square root of L squared plus W squared plus H squared. It's really the same thing going on here, length, width, and height. So if I went from an x coordinate of 5 to an x coordinate of 0, so that's 5 units in that dimension. The height was 10 units. Going across, I went from a 0 to a 6 is 6. So I could have just said it's the square root, you could call whichever one you want the length. I'll just do it the same way. 5 squared plus 6 squared plus 10 squared. So again, all I needed really was the length, width, and the height. And I'd arrive at the exact same answer. So the square root of 161 is the length of that diagonal of the box. And there you have it. 2 different methods to find the length of the diagonal of the box using coordinates.